Step 2, determining our critical F to define our critical regions for making our decisions. Same table. It's still the F distribution table at the back of your books, table B.4. It's the exact same table as last chapter, but note that we're going to have to approach it a little bit differently. So what do we need? As always, we need to know our alpha level, 0.05 or 0.01. We know that if it's a light face font, that's 0.05. The bold font is for 0.01. Across the top, degrees of freedom from the numerator. That hasn't changed. Our numerator is between treatments. So we want the degrees of freedom between treatments across the top. Down the side, degrees of freedom for the denominator. That's the one that changed, right? It used to be our degrees of freedom within treatments, last chapter, but our denominator is different. What are we using for the denominator? The error term, residual error. The error row on your formula sheet. The error row. So down the side, we want the degrees of freedom from the error box, not from the within treatment box, because this will have the individual differences stuff already subtracted out of it. So we need our degrees of freedom between treatments, and we need our degrees of freedom for the error term. When we get those things, we look up our critical F. And we graph where our critical region is located. Just like last chapter, we don't have these things yet. We haven't gone to calculations. So what I recommend is, as you're working through the problem, make a space for this work like I did right here, and then go back to it after step 3. Again, I highly recommend that you not bounce back and forth between steps 2 and 3 over and over and over. That's how accidents happen, right? Careless mistakes happen that way. So set up step 2 and then just move forward right into step 3. So let's talk about step 3 then. Step 3 is doing the math. It's a little smaller. Okay, so obviously I'm building my results table here, and we can see again that it's mostly the same as the one we had last time. We still need our between treatments for our numerator. So that variance, again, variance is sums of squares divided by degrees of freedom. So we're going to do these 3 boxes just like we had before. We also need our within treatments. Notice we only have to do the 2 of them. We don't need to calculate the variance or mean of squares within treatments. You can, but again, it doesn't help solve the problem, so we just skip it. Then notice these 2 are indented because they are parts of the within treatments. This is our stage 2. And remember, between subjects means individual differences. So here's where we're going to calculate our individual differences. Again, we don't have to calculate the full variance value because it's not useful, but we could. So we're going to get our within treatments, our total amount of error, calculate how much of that error is due to the individual differences between subjects' variance, and we're literally going to take this value this value and subtract it out to get how much is left over, that residual error, our error term. And then, of course, the values for the total study. So as usual, our values for between treatments and within treatments added together, so our sums of squares between and our sums of squares within treatments, these two added together need to equal the total. All those safety math checks are still in play. So with this written out like this, obviously there's not enough room for me to really write the formulas inside all of the boxes. But you have this handout, it's right there, so you can read all the formulas yourself. And you can see that for the ones that are boxes that we already know, the formulas are unchanged. So the only thing we need to do that I'm going to elaborate on here are the extra calculations for between subjects row and for the error row. Otherwise, it's all identical. So looking at your formula for between subjects, it's very much like your formula for between treatments. So again, I'm just going to zoom, if you will, in on this so that you can read it better. So if we're looking at our between subjects, our individual differences, first thing we need there is be able to calculate our sums of squares. And again, this is a very similar equation to our between treatments. So instead of looking at treatment totals divided by our number of scores, we're going to look at person scores divided by how many treatments they've gone through. So instead of the T, because we're doing individual differences, we're substituting the individual personal scores there, and divided by how many conditions they've gone through. And then we're going to subtract what we always subtract out of here, capital G squared over capital N. Then to calculate the error, our residual error or our error term, literally all we're going to do is take our sums of squares within treatments and subtract out of it the sums of squares between subjects, this thing we just calculated. So I mean it quite literally. We're going to calculate individual differences and just subtract it out of the study. So there's no other way to get to this. You just straight up subtract it. So these two values together should equal the value in the box that says within treatments. Remember, we're taking within treatments variance and breaking it into two parts. So its two parts need to add up to the whole as well. For our degrees of freedom, for between subjects, we are simply going to take the number of people in the study or number of scores in each condition and minus 1. That's our traditional degrees of freedom formula, right? Way back from chapter 4. Notice that because it's repeated measures, the little n value has to be identical. If there's 10 people in treatment condition 1 and we're using the same people over and over, recycling that way, then there'll be 10 scores in condition 2 and 10 scores in condition 3. They'll always have identical numbers through the numbers of scores through the treatment conditions. Our degrees of freedom for the error term, again, we're just going to subtract out. So you get your degrees of freedom for your within treatments and subtract out of it your degrees of freedom for between subjects. So we're literally going to calculate this box and subtract it out and take what's left over. And then the last piece here is to get your mean squares or variance for the error. You wouldn't have to calculate that one. And variance is variance. Sums of squares divided by degrees of freedom. So to get my mean of squares for error, I need my sums of squares for error divided by my degrees of freedom for error. So this box divided by this box equals that box. So if you need a refresher on the earlier formulas, you can go back and find those in the previous videos, but these are the only new things for us to compute to deal with in step 3. From here, we would go back to step 2. We would now have our degrees of freedom for between treatments. We would now have our degrees of freedom for the error term. We'd look that up and say, oh, my critical F is whatever value. And then, of course, the last step, as always, step 4, is to state your decision As always, as is eternal, there are only two decisions you can make. You're either going to reject the null hypothesis or fail to reject the null hypothesis. So if our F ratio or F statistic lands within the shaded area, within the critical regions, we're going to reject the null. If we land in the body, we're going to fail to reject the null. And writing this in our APA format is also the same, with only one tiny little difference. The format is identical. The only difference is when we're reporting our degrees of freedom, it's our degrees of freedom for between treatments, our numerator, but our denominator changed from within treatments to error, so numerator, denominator. So we just need to make sure we're reporting the correct value there. If you put in the degrees of freedom within treatments there, that is wrong. So, and again, less than if we reject, greater than if we fail to reject, and whatever alpha level you were working with, report there. So those are our 4 steps. Just like before, if we reject the null hypothesis and if we had 3 or more treatment conditions, we would have to do a post hoc in order to understand the results better. Again, as a student, you only need to do a post hoc if the question says, hey, you do a post hoc, but the logic follows the same. So there may be a step 5, there may be a post hoc step after this. We'll look at that later and see. Again, mostly the same. The only differences are about substituting out that denominator that we'll see. So in the next video clip, we are going to go to a problem in the book and work through our steps to see how that goes for us.